we'll continue with multiplication of 2 by 2 matrices. So you realize that for multiplication of matrices, it didn't make it general. We said for 2 by 2 matrix because there are a little more procedures that should be added to the algorithm. Right, so let's look at how multiplication of 2 by 2 matrices done. So multiplication. Right, sorry for my multiplication of matrices. Perfect. So let's see. To multiply a matrix, wait. Sorry. We have to begin from here. Sorry. So let's start. We'll start from here. Sorry. Praise the Lord, hallelujah, in the house, yes. So multiplication of a matrix by a scalar. Right. To multiply a matrix by a number, a scalar, multiply each element of the matrix by the number. That's simple. So let's see. If A is given by this, then let's use lambda. Lambda A will be equal to A lambda, right, multiplying, and that will be computed by lambda multiply each component, each element. Perfect. You see, let's try this example. Example 1. Calculate 2 multiplying the matrix 2y minus 2, 3. This will be equal to 4, right? 2 minus 4, then 6. We calculated this way. 2 multiply this, you write it there. The corresponding place. 2 multiply this, you write it here. 2 multiplies it here. 2 multiplies 3. So it's easy to multiply by a scalar. If we try this example, is multiplied by negative 3. So we get negative 3 here, right? It's being multiplied by negative 3. So in the end, we get negative 3, 0, 0, negative 3. These are easy subtractions and additions. For instance, let's see example 2. It says find C, where C is equal to 3A, right? It means we multiply A by 3, then we subtract B from that answer. So we first multiply A by 3. How do you multiply? Because 3 here is a scalar. A scalar is a number like an integer, right? It doesn't have vector components, it's just a scalar. Alright, so 5 minus 2, 3, 0. First multiplied by 3, then minus B. What's B? 5 minus 1, 1, 3. Let's try and calculate this. 5 times this is 15. 3 times this is minus 6. 3 times 3 is 9. And 3 times 0 is 0. Then we'll subtract 5 minus 1, 1, and 3. Then the answer will be 10 minus 5, 8, and minus 3. So, right, this is very easy. You could try example 3 on your own. It's just follow the procedure and substitute. Let's move on to multiplication of 2 by 2 matrix. In multiplying a 2 by 2 matrix, you should make sure that they have same number of columns in the first matrix, right, is equal to the number of rows in the second matrix. The number of columns in the first matrix should be equal to the number of rows in the next matrix. Why do we need this to be so? If this is not so, our multiplication cannot be computed. It wouldn't be valid. It will not be possible to add those numbers. Right, so let's see what this means. So we are here. If we have two matrices, A, which is a 2 by 3 matrix, and then we have B, which is also a 2 by 3 matrix. We cannot add them. We cannot multiply them. Why is this so? Because according to the rules here, the number of columns in the first matrix, first matrix is, if you are multiplying A, is A by times B, this is the first, right? And this is the second. But if it's B times A, then this is the first, then this is the second. Right. The number of columns in the first matrix should be equal to the number of rows in this next matrix. That means that number of columns, let's put our I and C. In the first matrix here, we have 3 in the columns, and how many in the rows? 2. Since they are not equal, we can't multiply them. So let's take a practical, another example where you can add, you can multiply them. Let's say C is a matrix that's an order of 3 by 2, and then D has an order of 2 by 3. Then we can multiply them, because if we do the row column thing, C has 2 columns, then D has 2 columns. Because of these two, we can multiply C and D, which becomes 3 by 2, right, multiplying a 2 by 3. So you should note this always when you are multiplying. The numbers in between, the numbers that are very close, should be equal. The numbers out here, right, outward here, can be different. This before, they could be different, but the numbers that are very in the innermost part should be the same. So let's take this example. If I ask you to multiply E and F, where E is a 4 by 3 matrix, and then F is a 3 by 7 matrix, will this be valid or not valid? Let's see. For if I ask you to calculate E times F, right, EF, then we'll have 4 times 4 by 3 multiply a 3 by 7, which is possible. But if I ask you to find F times E, then it wouldn't be possible, because we have 3 times 7 multiplying 4 times 3. These are not equal, so cannot multiply, but these are equal, so can multiply. So that is what you should know. And then they did the same comparison in here. The elements that are very close are the same. So let's move on to the general multiplication process. This is how we multiply two matrices A and B. So this is A and this is B. If we multiply A and B, then it means we have A, B, C, D, we multiply with E, F, G, H. How do we compute this? There are a little algorithms and steps we will follow to solve this. First, you should keep in mind that we will take them row-wise from the left. So we'll take them row-wise from the left. That means that from the A, right, which is on our left, we'll take the first row and then use it in the multiplication. Then we'll come to the next row. Then we'll come to the next row. Right. So in this example, there are only two rows. So there is this row and there is this row. So we'll take the first row. We take the first row. We take A and B, A, B, right? This is the first row. This is how you do the multiplication. The first row multiplies the first column of the other one. So I think we have the same RC, which I said you could memorize with remote control, appearing here. We'll use the first row of the first matrix to multiply the first column of the next matrix. And this is how we multiply. When you're multiplying, you only multiply corresponding elements and then you add them at the end. What it means is A will multiply E alone. So we'll have A, E. Then plus B will multiply G. Perfect. And this only fills the first part of it. Let's look at the next one. A will multiply the next bit. The first row will now multiply this column. And how do we do it? Let's see. A multiplies F, so that's AF. Then B multiplies G, so plus B multiplies H, BH. Perfect. Now let's take the next one. We are done with the first column, the first row. Right. We took the first row, and this first row we took from here gave us the first row on the product side. Now let's take each column, the next row, sorry. We have the next row, which is CD. So we assume the CD should give us the next row of elements. And then in each one, the first column will just give us the first half, and then the second column will give us the second half. So let's multiply. CE, sometimes it's just advisable to keep it in alphabetical order, but there is no restriction. Plus DG, then CE, CF plus DH. This is perfect, so easy and so understandable, right? So we do it row-wise from the left. Take the first row, multiply both columns of the second matrix. Take the second row, multiply both columns of this matrix, and put them together in here to form your product. We'll take examples in the next mark.